Hello, everyone. I'm Anessa Goodwin of Key Performance Ideas, and I'd like to welcome you to our webinar today, How to Leverage MDX to Automate and Streamline Your Reporting Processes, presented today by Jennifer Hanks. Jennifer Hanks, a seasoned finance, accounting, and IT professional, started as an end user of Hyperion Enterprise and Hyperion Financial Management, and moved into financial systems administration of Hyperion S-Base, Hyperion Planning, and the associated reporting tools. With over 15 years of analyst and system administration experience, she has a deep understanding of the needs of leadership and business users and can translate their needs into complex technical requirements. Jennifer is a recognized thought leader and frequent speaker at industry events, including K-Scope by ODTUG. Thank you, Jennifer, for joining us today.
Thank you, Anessa. Okay, so today, in talking about MDX, this is the agenda we're going to have. We're going to talk about some basics of MDX, talk very quickly about some BSO to ASO conversion, cover some keys to success and lessons learned. We'll cover one example of a complex formula, and then we'll have a Q&A session. So MDX, what is it? It's basically a method for querying and manipulating your multidimensional data that is found in S-Base, and it is also the query language for other OLAP databases such as Oracle BI, Cognos, and Microsoft Analysis Services. The technical uses of MDX, you can use it within member formulas of ASO cubes, which is where we're going to focus most of our discussion today, but it can also be used within the MDX script editor to write reports, and from that you can query both BSO and ASO databases, and for those who are familiar with SQL, it's written very similar to that, where you're going to select your members from your dimensions on your rows, your members from your dimensions on your columns, from your specific database, and you even have your where to select your parameters. So it's very similar to SQL in that regard. And then the other use is you can pass MDX through Maxell to S-Base. So what are some of the business uses? So that's the technical use. What are the business uses? Well, pretty much anything you can think of. Here's just a few that I personally have used. You can do periodic averages, so you can do a rolling 4-week average or rolling 3-month average. You can do some trend analysis or run rates to be able to project out your future time periods based upon your most recent ones. You can do some salary projections. I've seen it used to do turnover analysis. And then it can also be used, we've used it within financial modeling using KPIs, drivers, and other assumptions to kind of do some business modeling for management. Okay, so one of the first things that is important to understand is that there's different types of functions. So by types, it means what you're going to return. So you have your basic mathematical functions that are going to perform a calculation, and those use your symbols. Then you have other functions that are going to return either a member, set, or layer. And those are going to be pointing to your members that you're pulling from your dimension. So if you're pulling a single member, you could pull your parent, the child, the first child, the last child, your ancestor, but you're basically just pulling one member. You can also pull a set. Then those include your cross-join, your intersect, tails, children, where you bring back all of your children. And then there's also member range and filter and union, which we're going to see in our example today. Layers bring back all of your levels or generations. Number is where you're going to get into your other calculations. These are the ones that you've probably seen in a variety of different places, including Excel, where you can you can calculate an average, you can do a count, you can sum some data, you can pull the maximum, the minimum, even your mode, median are in there. There's some date functions if you have date type measures in your cube. And then your Boolean functions are also extremely important, and these are functions that are going to evaluate to true or false that you can use within your conditional statements to determine what data you're going to perform a calculation on. Okay, so moving on from that, let's talk about MDX syntax. First of all, it is not case sensitive. Next, we use bracket around our member names if there's spaces. Now, if there isn't a space, you don't need to use brackets. The brackets are only required if there is a space. You can identify your member by stating your dimension dot your member, but that is optional. You also could just put your member name. So if you need to put your dimension to know which dimension a member applies to, then you certainly can do that. And then your current member is used to return a current member that you're doing the calculation on. So if you are on your period dimension and you are on January and you've specified period.current member, it is going to perform that calculation on January because that's where you're retrieving the cell from. And just as a general rule, it's good to be consistent throughout when you make a choice, if there is a choice. So for example, with the brackets, I tend to say I always use brackets because if there's spaces, I'm going to need them. I don't necessarily need to, but it's just a little bit easier to read that you always know you're looking at a dimension if there's brackets around it. If you're going to specify your dimension dot your member name, then do it throughout. Don't just do it for one of your dimensions. It just makes the code a little bit easier to read and follow. Okay, so here's some basic examples, some simple equations. So the first one is using your symbols to basically do your units divided by your transactions. The second one is a simple sum statement where we're going to sum the members of January through March. And you can see we've listed them there just with a colon between them. And that's basically going to calculate January through March for whatever measure dimension you're on at the time that you're retrieving. The next one is a little bit more complex of a sum statement, and here we're actually showing the member range, where we're going to sum the member range of January through March for just our units measure. So again, you can see an example here of where we specified our dimension dot our member versus the one before where we just supplied our member. And then the final one is a very simple case statement, and this is our conditional statement that we like to use in MDX, and you're basically saying case when your geography generation is 2, then I want you to do units divided by transactions, and whenever you have a case statement, you always have to have an end statement to end that case. So those are some basic examples. Let me show you a complex example. I'm not going to delve too deeply into it because it is going to be our example we're going to walk through, but this is an example of where I've combined 5 different functions into one, nesting them together to do a more complex calculation. So again, we will walk through this in detail, so I'm just going to move on for now. So let's talk ASO to BSO conversion. The first thing is syntax. There are syntax differences. In BSO, we use double quotes around our members, and in MDX, we use our square brackets we were just talking about. No semicolon is required at the end of a function. Cross-dimensional operators are now replaced by commas and parentheses. So instead of having our little arrow cross-dimensional operators between each dimension, we now just have a comma and then we enclose the entire string within parentheses. So when you go to do formula conversion, there's 2 different types of conversion. You can have a direct counterpart in MDX, and basically what you're going to see is the exact same function just without the at symbol at the beginning of it. Then you have your indirect translations, and these are where the function has completely changed names. So a range is replaced with a cross join in MDX. Descendants is actually replaced with is ancestor. So instead of looking for the descendants of quarter 1, you're now going to say where I want to pull where quarter 1 is the ancestor of my current member of period. And then the process to actually do the ASO conversion, we strongly recommend that you use the ASO outline conversion wizard. It does the bulk of the work for you, and that's where you start with the BSO outline, run it through the wizard, and it's going to convert most of your formulas for you. It's going to do all of those direct counterpart MDX conversions for you, and it's going to change all of your syntax for you, and then it's going to leave you with just those more complex formulas or where there maybe isn't a direct translation for you to just address maybe a handful versus all of your formulas. So it's always good to start with your ASO outline conversion wizard and then just handle your exceptions. Okay, so let's move on to an example, but before we do that, I just have a little quick disclaimer here. Most times there are multiple ways to write the same formula. So just because I do it one way here, it doesn't necessarily mean it's the same way you would do it. Is one right and one wrong? Well, not necessarily. So when you see the different methods and you're working through, things you want to consider as you're looking at those methods are, first and foremost, does it return the expected results? Next is retrieval time. If you're going to use this in Financial Reporting Studio or you're going to pull it back in SmartView, obviously the one that retrieves the quickest for you is most likely going to be your most efficient and the one you want to use. But then there's also some kind of fuzzier ones. Ease of reading. What's easier for you to read? And this goes back to what we were just talking about. Do you want to see the brackets around everything? Do you want to see your dimension, then your member? Just what is easiest for you as a developer to use. So a lot of times it comes down to personal preference. Okay, so on to keys for success. Before you start, you want to define your exact formula. After you have your exact formula defined for you, and you may need to go to the business to get that, you want to then mock up an example with actual data points. SmartView is great for this. So if you're going to be doing an average of 3 months, pull back your 3 months with data points, and in Excel, create an average column that averages them for you so you know what you want your end result to be. And then consider how the formula is going to be used. Are there different variations you need to consider? Do different lines of business need a different calculation or need to use different assumptions or different variables? Basically, this isn't necessary from the get-go, but it is certainly nice to have because you don't want to have to go back in and do rework or completely redesign a formula because you weren't aware of some variation. It's not to say it won't happen, but if you try to ask some very pointed questions up front, it can give you your best design to start out with. So some of the things that I've learned in working with MDX, first and foremost, start simple. If you want to write out your entire framework and only work on one section at a time, you're going to work one section at a time. But if you want to write out your entire framework, then you can use dummy values in sections you aren't working on to at least get your framework set to begin with. It's always good to create dynamically where possible. It is not nice to have to roll functions forward or formulas forward from year to year, quarter to quarter, whatever the variation is. So to do that, you may want to consider hard coding it first. Once you get something working, you're getting your expected results, then you can go back and you can try changing it to dynamic and making sure you still get your same results. If you can start out doing dynamic, great, but sometimes if you hit a wall, it's easier to just hard code first and then go back and do the dynamic later. If you have a formula that's working and you want to modify it, always have a backup, whether that means copying and pasting it into copying and pasting it into like a text pad, or whether that means copying and pasting the entire function and commenting it out below in the same window so that you have it should you need to revert back to it. And then keep notes within complex formulas of who and when last updated, maybe the purpose of the calculation, maybe even a brief description of what the calculation is doing. If you were to move on to another position, if they were to hire somebody to come in and help you, if you have multiple people in that database working, then it's always good to kind of have notes as to who created the formula, when was it last updated, and what is it trying to do. It gives you a point person to go to and kind of a little description of what it's trying to do. For long formulas, consider comments at logical breakpoints. So if you're doing a different calculation based upon the line of business, maybe just insert a little comment at the beginning of the calculation for each line of business 1, line of business 2, line of business 3. It makes it so if you ever need to go in and troubleshoot the formula, you can either search for your line of business 2, or you can at least see the green and scroll down until you find it. Just makes it a little bit easier to look at. In addition, you can also do comments when you're doing some more complex calculations, you can define what the calculation is doing at each step. I've had to do that once before. Next, if a formula gets too complex, you might want to consider breaking it into multiple member formulas that build upon each other, and then using your solve order to have them calculate in the correct order. Sometimes you can the code gets so complex that it's just too difficult to read or follow, and maybe you can get it to work, but it might be really hard if you ever need to go back and look at it again. Benchmark your different ways to do your calculation, retrieve them, find out which one's the most efficient to figure out which one is going to be the best one. If you get stuck, review the available functions that are out there in the documentation or even within the window with which you're building MDX and see if there's any applicable. I've actually found some functions out there that fit my exact need that I didn't know existed when I started learning MDX, and that's really how I got to have a firm handle on the available functions. Is go out there and look at what's available. Maybe there's something you never knew existed. And then when you're writing a formula, always consider the future. Keep it easy to read and work with. That's where your notes come in, where your consistency comes in on your syntax. Just make it so that if somebody else has to come in and look at it or work with it, that they can. Okay, so we're going to do our example. This is actually from the ASO sample database. I am simply adding a member. Everything else in here already exists, so this is something if you wanted to go in and recreate it within your ASO sample database, you absolutely could. So the example that I'm using is we're going to calculate a 2-month average units where the sales type transactions are greater than 30,000. So we got the description of the formula. I've mocked it up in Excel here. We can see where I'm pulling my current year, my previous year, my units, my transactions, monthly, and then my sale over there on the far left is my type of transactions. And the colored cells over here, the yellow, blue, green, and orange cells, indicate where I have created a formula within Excel to mock up my results. Now the color coding is where I've gone in and looked at it and determined the different parts of my function. So for January and February, to get a 2-month average, I'm actually going to need to go back and look at the previous year. So those are yellow. All of the blue, the calculations can be done within the current year. And then my green section here, my August through December of my current year, basically those aren't going to be valid results, so we don't want to calculate anything for them. And within the ASO sample database, we only have 2 years, current year and previous year. So my January of my previous year is actually not going to be a valid result either. So just taking a quick look at what I just described, when you have January, you need to average January of your current year and December of your previous year. And then for May, we need to average May and March. So we're going to skip over April in this instance because their sale type transactions are not greater than 30,000. So the first thing that I do when I look at this is I want to restate it into an easier language for me to understand. So I'm going to evaluate the current period and the prior periods with a filter where sale types transactions are greater than 30,000 and then return the average of the units for the most recent 2 months. And what I get out of that is I want to do an average, I want to do a filter, and I want to use our tail function. So the first thing we want to do is we want to get our set of transactions where the sales type are greater than 30,000. So to do that, we're going to use our filter function. This is the syntax from the technical reference. We're going to filter a set based upon a search condition. So our set is January through our current month units, and our search conditions is where sales type transactions are greater than or equal to 30,000. So this is the formula we end up with. I'm doing a cross join here of January through my current member for time for my units. I'm joining those, and then I'm doing a filter where my transaction type of sales and my transactions are greater than 30,000, greater than or equal to. Notice I put all of my other dimensions in here because one of the things one of the assumptions of this calculation is we don't want to perform this calculation based upon the sale type transactions at each store or each product or each of these other dimensions. So I'm going to pull it at the highest level, so it's doing the filter on that highest level only. So after we get our set of data that meets our search condition, what we're going to do with that next is we're going to take the last two. So that's our tail, and again, it's tail of a set with an index. So our set is our January through current month units where the sales type transactions are greater than or equal to 30,000, which we just defined, and our index is 2 because we want the most recent 2. So all I've done here is I've only added the blue section. I've added the tail with an open parentheses at the beginning and a comma 2 with a closed parentheses at the end. Everything else is the same as what we just did. So now that we have our most recent 2 months, what do we want to do with them? We want to do an average. So the syntax is set with a numeric value expression. Our set is what we just defined, and our numeric value expression is what we want to average, which is our units. So again, everything that you're seeing here is the same with the exception of I've added the average and I've added the units of what we wanted to average. So what I just created was actually our March through December calculation because it's doing the calculation all within the current year. So in this instance, we're going to go ahead and just start with that. Once we do that, we can go back and add our January calculation. So building upon that, I've added a case statement around it and said when my time is January, then I actually want to look at, and this is the exact same formula, I've just changed the cross join to be my previous year November, my previous year December, and my current year January. Everything else is the same before and after that. It's just your cross join of which members you're looking at. And then my else is what we defined as we walk through those steps, my March through December calculation. After we get January set up, we can add February. Also, let me just point out, at each one of these steps, you should be validating your data and making sure you're getting your correct results. So after we validated March through December, we add January. After we've added January and we validated it, we can move on to adding February. So we're seeing our same January statement, and now I've added an additional when section for February. And again, the only thing I've changed is my cross-join section to look at December of my previous year and then January and February of my current year. And then my else still remains the same. So if I go in and validate my formula at this point, we'll see that my yellow and blue sections now tie out because I've added check columns, and I now need to go in and address my orange and green sections. So let's go ahead and do the green section next. This can be simply done by adding a non-empty check. So we use our non-empty member, and then you can use any dimension that is going to be populated for the given month. So a lot of times what I use for this is revenue, because if a month has data in it, it's most likely going to have revenue, and that's how you kind of determine your dimension. So here I just picked price paid. So basically it's saying only perform this calculation below if price paid is not pound missing. So now we validate the formula. We see the green has gone away. And now I can modify January for current year and previous year. So basically I've gone into my January statement and I've said where my time is January, but my year is not previous year. And when we do a validate after that, you'll see that our orange cell goes away and that checks out. So this is our final formula, but let me go ahead and show you an alternate way to do that formula. And all I've done with this function is combined my January and February when sections into one. So I'm now saying when it's January and not previous year, or when it's February. Now my cross joins, I have two of them with a union. And I'm doing kind of the same cross joins. I'm doing a cross join of January through December of my previous year and January through my current member of my current year. And that union is allowing us to look at both sets at once. Does this need to be done? Absolutely not. This is just one way that you can continue to kind of refine upon formulas, so I wanted to show that. So that's how we can create some of the more complex formulas. It seems kind of common sense when you stop and think about it, but sometimes when you're digging into the code, it doesn't become apparent. So now that you've created your formulas, let's talk about troubleshooting formulas. So you're going to follow a very similar step. In order to troubleshoot the formula, once again, you need to define the formula, know your results. And before you start modifying any formula, you always want to check your solve order and make sure that if your formula references another member formula, that your solve order is correct so that you can perform the calculation correctly. So once you check your solve order, then you can go in and start troubleshooting. For complex formulas, I recommend breaking it into pieces. So comment out all but one section. If you have only one section that's not working, then obviously that's the one. If you don't know or you have multiple sections that aren't working, just pick one and start looking at it. So comment everything out except for the one section. For case statements, determine if your problem is in your when or your then statement, because sometimes you can start working on your then statement and modifying the calculation, but really the problem is your when statement isn't doing what you think it's supposed to do. So always make sure. The way that I typically do this is when you're first starting is comment out all of your then sections and replace them with dummy values, so a 111, 222, 333, and then retrieve your data and make sure that in the cell you're trying to troubleshoot that you're seeing the dummy value that you expected to. So you make sure that your when statement is correct before you start modifying your then statement. Okay, so that was kind of the bulk of the material I wanted to cover. So to wrap up, for conversion, start with the outline conversion wizard, let it do the bulk of the work for you, and then come back and just address those exceptions. When you're doing a formula, make sure you know what a function is going to return. Is it going to do a calculation for you, or is it just going to return a member or a set or a level for you? So sometimes when you're pulling those, you need to then do a calculation on them. When you're writing the formula, have a solid definition of the formula and what you want your expected results to be. Work in steps. Your order doesn't matter. Again, in our example, we actually started with the March through December. We very easily could have started with January as well and then worked our way down. It doesn't matter. Just pick a section and start. Validate each step as you go. Last thing you want to do is think something is working and it's not, or write a big chunk of code and then go to validate it and it doesn't work and you're having to go back through it and figure out where your problem is. Don't be afraid to experiment with new formulas. Go and look at what's out there. Try to make something work. If you think it's something that could work for you, hack away at it and see if you can get it to work. There's no one right way, so try your different ways, benchmark them, see what's the most efficient and makes the most sense, and then follow the same process when you're troubleshooting as you did when you built the formula. And with that, we can move to questions.
Thank you, Jennifer. To ask a question, go to Viewing Desktop at the top of your screen and select Chat. This presentation will be available on our website in a few days. There's a few questions about getting copies of it.
All right, so we do have a question, and the question is, what tool do you use to run the MDX queries? Within Essbase, within the member formula itself, you can write your MDX directly within EAS. Additionally, there is an MDX script editor that you can use, again, within EAS. So this is a built-in S-Base functionality within S-Base. So within EAS, you can go in and write your MDX either directly within the member formula, so making the member a dynamic calc and then going over to the formula and writing the formula within there, or you can do the MDX script editor, which goes back to defining your rows and your columns, because it's going to produce an actual report for you.
Jen, here's another question. Your example used a case function to perform a conditional test. There's also an if statement. Can you explain the difference or when to use each one?
Okay, absolutely. So we did talk a lot about a case statement, and it's really a little bit of personal preference. An if statement allows you to do one conditional test, one else statement. You can nest them within each other, but it's really if this, then this, else this, and as opposed to a case allows you to do multiple conditional tests. So that when and then you can have multiple in there, and then you can also have your else still at the end. So you could perform 10, 20 different conditional tests versus just the one and having to nest the if statements. So that's really the difference. There's some very smart people out there that have written blog articles about whether there is a performance difference between the case and the if statement, and really it comes down to there really isn't a whole lot. I've seen one person who says there is, but they say for the most part that there isn't a lot of a performance difference. So I tend to always go to a case because I just think it's the most functional. Another question is, can this also be done in Excel? Within SmartView, there is an option to execute an MDX query. I wouldn't recommend it for a beginner. It is similar, your syntax would be similar to a report where you select your dimensions on your rows and your columns from a database and then with your conditional where statement, but there's no validation check for it, so you would have to type in your formula, execute it, and if it errored, it would tell you there was an error, not what that error was, and then you'd have to bring the box up and it would be blank again. So that's really, it's useful. I've definitely seen it, but you have to be experienced at using it.
I have this question. Can you explain what solve order is and how to use it?
Okay, so our solve order is basically a number that we can put on each one of our member formulas within S-Base. And what it does is it determines the order in which calculations are performed. So one example would be if you have a 4-week average and then you use that 4-week average in a run rate calculation or a trend analysis. But let's just go with run rate. You would perform that 4-week calculation and you might give it a solve order of 10. But then when you go to perform your run rate calculation, then you would need to give it a solve order greater than 10 because you're referencing that 4-week average number. So your solve order basically is just going to tell the database in which order to solve everything. And that's one of the big changes between BSO and ASO when it comes to these, is BSO only allowed 2 passes over the database. With ASO, you can assign all kinds of different solve orders. I think, you can solve like upwards of, I think it's 2 digits, so 99 different solve orders on there. You clearly wouldn't want to do that, but you could. And so it's just the order in which your members are going to be calculated. Another example of when solve order might be important is if you're doing an average and you also have a percentage in the database, you would want your percentage to be done after your average, because you wouldn't want to average your percentages necessarily, or maybe you would. But that's one of the times when you really need to look at your sub orders when you're dealing with percentages.
Jennifer, let's take one last question. In SmartView, there is an option to execute MDX. Does this mean I can write or execute MDX in SmartView?
Yeah, actually we had a similar question to that a few minutes ago, and basically, yes, you can. There is the ability to execute an MDX query that is written with your select these dimensions on your rows and your columns from a specific database with your where clause. I caution against it for people that are new to MDX because it does not give any type of error. It gives you an error, but it doesn't tell you what is wrong with your syntax. And as soon as it doesn't work, it starts you with a blank page all over again. So really, when you're learning MDX to start with, you want to start within the tools. You want to start within either the member formula, writing the MDX, or whether you want to start within the MDX script editor if you were writing more of a report. But those are kind of the two tools if you're just starting out with MDX you want to go to. If you are more accomplished with MDX, then absolutely SmartView does handle the ability to kick off an MDX query, and it works in tandem with the SmartView functionality, so you can be picking things in your POV and also using an MDX query. It's a very neat tool, but it's definitely for somebody who already understands how to write good MDX.
Well, thank you, Jennifer, and thank you all for joining us today for the webinar, How to Leverage MDX to Automate and Streamline Your Reporting Processes. If you have any additional questions, please don't hesitate to contact us. Jennifer's and Greg Allman's contact information is displayed on your screen. And again, thank you so much for joining us today, and have a great one.